This video will show you how to solve flow rate questions that are solving for drops per minute. And the reason that I know both of these are drops per minute is there's mention of a drop factor and burette. A burette is a term used for a standard type of tubing that has a flow rate, or drop factor rather, of 60 drops per milliliter. And then if you see mention of drop factor with a number tied to it, that number is going to be associated with, again, drops per milliliter. So in this case, it's 10, but you might see 12, 15, 18. It just depends what type of tubing it is. All right, we know we are solving for drops per minute. That's always the first step, is identifying what units you're solving for. My unit in the numerator is going to be my starting point over on this side of the equal sign. And I know that 10 means 10 drops per 1 milliliter. The unit on the bottom is going to be placed up top, and you can't see, this is actually a little milliliter there. So we have 250 milliliters, and that is paired with 500 milligrams. I can cancel out my milliliters, and next is going to be 150 milligrams. And then this is tied to 45 minutes. We're giving 150 milligrams over 45 minutes. Now looking at my goal of drops per minute, I can see I already have drops on the top and I have minutes on the bottom. That indicates that I don't need to continue pulling things from the question because I've met my end point. I can multiply across and divide by the bottom. This will be 22,500, and when divided, this is going to be 16.6 continued. When you're looking at flow rate questions, especially drops per minute, you literally are counting how many drops are dropping in a minute. So counting 0.6 of a drop is impossible. You'll likely be required to round this number. In this case, we have 0.6, so we would round up, and the answer would then be 17 drops per minute. Now try to solve this one on your own. Again, we are solving for drops per minute, and I know that because I see mention of a burette, and that burette has a factor of 60 drops per 1 milliliter. I'm going to place milliliters up here, look for it in the question. I see it here. It comes with 120 milligrams. Now I know I need milligrams up here so that I'm able to cancel out the milligram down in the denominator space there. And I see 3 milligrams per kilo per day. Next, I can work on my kilograms, and I see that this patient is 80 kilograms. The weight and body surface area are bachelors. If you have body surface area number, a meter square number, or you have weight, they are typically over just 1. Next, I need to contend with the unit of day, and I don't see it very directly, but I do see that we have 2 divided doses, and this should be per day. The person writing this question forgot to put that part, which would be me. All right, so we have 1 day, 2 doses. That cancels my day. And then now I have to find a way to get rid of dose. And looking at what I have left, I've used this. I've used these objective numbers. The only thing that I can see is this 120 minutes, which would fit with one dose because we're going to give one dose over 120 minutes. That allows me to cancel dose. I'm left with minute on the bottom, drops on the top, and that's what I needed. I can stop, multiply across, divide by the bottom. That gives me 1,440,000 divided by 28,800, and this gives me 50 drops per minute.